how our discussion goes. So the question is, which molecule, ADP or ATP, is more like a charged phone battery, and which one is like a dead phone battery? So Lucas, what did you write down? Okay, yes, that's a correct version of the analogy. So go ahead, Ashley, write above ATP, write charged phone battery, and ADP is a dead phone battery. Okay, ATP, that's our charged battery, and ADP, that's a dead phone battery. That's the place you don't want to be. Okay, I think, what iPhone number are we up to now? 16. 16. Were you alive when the first iPhone was created? Yeah, because you guys were born in 2007. Yeah, you were born right when that was when the first iPhone came out. So when 4, that was the first one you probably remember, is iPhone 4, probably, would you say? The first one you probably remember seeing is probably an iPhone 4. And iPhone 4 is pretty good. I'll give you a history lesson. iPhone 5, guess how that battery performed? Just guess. Like total garbage. It was terrible. So what people had to do back in those olden times, I'm talking like with the dinosaurs, they had to get a phone case that had another battery on it, and then they stuck it on there. Okay, and then the phone became like 2 inches longer because of that extra battery. That's what people had to do because the regular battery would die in like a few hours. It would just be gone. It wouldn't last all day. Like, will your battery now last all day? It should. Yeah, it probably should. You know, whatever phone you have, it should last all day. What about 2 days? Could it go 2 days? If you do it right, it probably could go 2 days even. That it would happen back in these old. But then iPhone 6 and beyond, they improved it quite a bit. But iPhone 5, that was a problem. What difference do you see between those two, Julian, between ATP and ADP? What's the difference? Ooh. Okay, so you're talking about the H right here? Okay, you're close. Like, look at this group of molecules, of atoms. What's missing in ADP? Like, what do you... Look at that. On the right side, it's the same, right? It's the left side. So what do you see on the left side? You don't count things up. What do you see? Six what? Oh, 6 O's? Okay. So these are oxygens, these are phosphates, and that's a hydrogen. Okay? So what these are called phosphate groups, based on the phosphate and then the oxygens. How many phosphate groups do you see in ATP? 3. Yeah, thanks, Shazleen. So go ahead and write 3 phosphate groups here, Ashley. Or you could circle them. 1, 2, 3 phosphate groups. And that's where that T comes in. What do you think that T stands for? If you have 3 of something, like in a triathlon, how many sports are there? Ever heard of triathlon before? There's running, swimming, and cycling. So there's 3. So ATP, that's triphosphate. So Ashley, can you write tri? Tri, and then put equals 3. So the tri means 3. So 3 phosphates. How many phosphates are in ADP? 2. So only 2. D stands for, what's a prefix that means 2? Well, bi does. There's another one. Kind of rhymes with bi. Di. Yeah, di. So that's adenosine diphosphate. So when you have the 3 here, that's charged and ready to go. Once you use this molecule, it loses a phosphate group and then becomes 2 phosphate groups. But the nice thing is, what can your body do with this ADP? Can it add a phosphate back on? Yes, it can. And that's the whole point of cellular respiration. It helps to rebuild the ADP turn into ATP. Why don't you write that down? Can you write that down? Ashley, over here. Cellular respiration turns ADP into then your body can use for energy. You have to write that part. Cellular respiration turns ADP into ATP. It creates energy molecules. CELLLAR. Then, yeah, you know, respiration. Respiration. Takes ADP and creates ATP. And those sound similar, right? It can be easy to get those mixed up. Think about tri and di, all right? Hopefully that'll help you remember. 3 has the energy, 2 does not have the energy. You need that 3 in order to have the energy. Right? It changes, yeah. Just write ADP and then an arrow ATP, showing that respiration changes ADP to ATP. Cellular respiration makes ATP basically, but it doesn't do it from scratch. It takes a molecule and just adds. And that's a lot easier than rebuilding the whole thing, right? Just adding a phosphate back on there. Recycling. That's what's going on. Okay. All right. Thank you, Ashley. Appreciate that. Today, we're gonna work. We're gonna start out nice and easy. We're gonna do a find someone for who knows the most about winter in here. Who's a winter expert? Anybody? No, you guys love winter, right? This is your favorite season, for sure. You can get cozy, wear your coats, wear your hats, earmuffs, scarf. You don't get hot. I know you guys love it. So we're going to find out who knows the most about winter. So your cell phones need to go away totally. So put those in your pocket. They can't come out at all. If they come out, you might lose your points on the whole thing. So no need to do that. Don't need to risk that, right? You guys have the answers up here. Remember, if you don't have the answer, just guess. It's okay. A lot of times our guesses are correct. Okay, don't second guess yourself. Just go for it. I want you to practice. You got to take measured risks in your life to be as successful as you. My main failures have came in my life when I just won't take a risk that I know that will be okay, but I'm just scared to do it. So don't be scared. Do it. Okay? Should you be scared to jump off a roof? Yes. That's not good. Don't do that. But getting up in front of a class to give a presentation, is that scary? Yes. But you should do it because it's not gonna kill you like jumping off a building would, or various other very risky behaviors that sometimes people get involved in. So take these measured risks. Got to do it. Okay. So everybody's phone is put away? Okay.